Hello Stats class, we're going to go over a little review of confidence intervals and hypothesis tests. The big idea, like how do I know which of these calculators to use given the scenario that I'm given. So the way that you're always going to start this process is you got to determine, do I have a confidence interval? Do I have a hypothesis test? So the way that you're going to know is the wording of the problem. If it's a confidence interval, you're going to see things like construct a confidence interval, or things like estimate the true value of some population parameter like a mean or a proportion with blankety blank percent confidence, usually like 95 or 99% confidence. But you're going to see this word somewhere in there. The word confidence is typically going to be present when you have a confidence interval. Right? When you have a hypothesis test, you're going to see things like test the claim. Right? When you see test the claim that blah blah blah, the fact that it says test the claim means you're going to use a hypothesis test. You'll also see things like alpha equals 0.01 or 0.05. The level of significance is what this is referred to as sometime. And if they say things like that, then you know you're dealing with a hypothesis test. So test the claim at the alpha equals 0.05 or 5% level of significance versus like 95% confidence. You'll see, if you see these big 90%, 99, 95% numbers, you're typically dealing with confidence intervals. But if you see small numbers like 0.05, 0.01, 0.1, along with the phrase test the claim, that means you're dealing with a hypothesis test. Now, once you've determined that, which one of these you're going to construct, then it becomes what parameter am I using? So let's look at confidence intervals for a second. A confidence interval for this class, we're only going to look at means and proportions. So I'm going a 90% confidence interval for the true value of a mean or an average. I'm doing a 95% confidence interval for the true value of a proportion of the population or a percentage of the population. So if the wording of the problem leads you to believe that it's a confidence interval, and you see in there that you're estimating a percentage, then the Desmos confidence interval calculator that you want is the Z interval for a proportion. So I've got that highlighted here. So these are grouped together. The confidence interval calculators are grouped together. And if it's a confidence interval about a proportion, you're going to select that calculator. Right? But if it's a mean, we have to break it down even further. Do I know the population standard deviation or not? So if I don't know the population standard deviation, then that is going to be a T interval for a mean. All right, and I would use that Desmos calculator. But if I do know the population standard deviation, which a lot of times is sigma is the label that we use for that, then I'm going to use the Z interval for a mean. All right, we'll look at an example in just a second, and we'll follow this path. Which one of these calculators do I use? These are always grouped together. It's just this is the hierarchy for how do I pick the Z interval for a mean, the T interval for a mean, or the Z interval for a proportion. All right, now when you have a hypothesis test, you're going to start off with that same question. Is it about a mean or proportion? And if it's about a proportion, just like it was with the hypothesis test, there was only one solution. There's going to be only one thing we're doing. We're doing a Z test for a proportion, but the wording of the problem could state that we're looking for a test that's below the claim value, above the claim value, or equal or different than the claim value. So if it's below, then you're going to do a left tail test, because again, think of the bell curve. Like the claim value of the parameter is going to be in the middle. That's the proportion in this case. But if I think it's below that, then I think I'm going to be over here to the left side. I think I'm going to be below it, so I'm in the left tail. All right, and then equivalently, if I think it's going to be above it, then that means I think I'm going to be over here in the right tail, because that's above the claim value. And then if I don't know, if it says equal or different, and we're just testing, and it doesn't specifically state above or below, then we could be in either of two tails. We could be below or above. We're just not equal to this number. We're different from this number. So those are the different criteria. Is the wording of the problem will determine which of the tests that we're going to do. If the wording is not specific to above or below, like greater than, less than, more, less, fewer, then we would assume that we're testing for an equal or difference and just do a two-tail test. All right, so it's got to specifically state that we are looking at something above or below to know to do the left or right tail test. Now, the same thing happens once we break down the mean into do we know the population standard deviation or not. If we do, then we go into the questions. Do I have wording that says it's above, below, or different? If so, it's a left-tailed, right-tailed z-test like it was for the proportions, but now it's a z-test for a mean. Right? So z-test for mean because it is about a mean, and I do know the population standard deviation. All right, but if I don't know the population standard deviation, when I answer those above, below, and if it doesn't state it, then I'm doing left, right, or two-tailed t-test. So again, t corresponds to not knowing the population standard deviation and test about a mean. All right, let's look at some problems and see if we can tell which of the calculators that we need. So here's a question that says a professor wants to estimate how many hours per week her students study. A random sample of this many students had a mean of this many hours per week. All right, construct a 95% confidence interval. So right there, confidence interval. I know that I am over here on this side of the hierarchy, confidence interval. Right, and then if you look at the wording of the problem, for the mean number of hours, so I know I'm doing a confidence interval about a mean. Right, now the question I ask is, do I know the population standard deviation or not? So again, they'll use that Greek letter sigma, or they'll write the word population standard deviation. Assume the population standard deviation is known to be this. So given all of that, I do know the population standard deviation. I'm doing a z-interval for a mean calculator. I would click that, I would put in the values, and I would have my confidence interval. So here is a single sample inference calculators in Desmos that we would use for this. There's that z-interval for a mean. If I click that, again, here is the wording of the problem. So n is how many in our sample, so that's 66 in this example. The standard deviation for the population is known to be 2.2, so I'd put that in there for S. M is the mean, so it had a mean of 15. You can just override these numbers every time. And then the confidence level, C, is 95%, so I'd make 0.95. Make sure you write it as a decimal. All right, and then if you scroll down to the bottom here, you can click on this little plus, and that'll give you the range. It also gives it to you here with the L and the U. All right, round these to two decimal places, so this one would be 14.47, and this one would be 15.53. Okay, if you aren't comfortable with rounding, you can even use these calculators and grab these numbers, and down here at the next open spot, write round, paste the number, and then tell it to two places, and it'll round these things for you if you're not comfortable rounding. All right, so these, you can also, right there, they got it rounded. You can also change those to round to two places, however many places the problem tells. So you can do it right there as well. All right, let's look at another example. All right, this one says an automotive manufacturer wants to know the proportion of new car buyers who prefer foreign over domestic. So there's the sample. Of the sample, this many preferred foreign over domestic. Using the data to estimate the proportion who prefer foreign cars. So I'm estimating a proportion. It does not say necessarily to do a confidence interval, but it does right there in the next part. All right, but the fact that this one says estimate the proportion, that leads me to believe that I'm going to do a confidence interval. If this came at you in part 1 and then part 2. Because confidence intervals are estimations of parameters. So if I'm estimating a parameter, I'm not doing a hypothesis test. That lets me know I'm going to do a confidence interval. But again, the second part will give it away. It specifically says confidence interval. So again, I'm up here. I'm doing a confidence interval. This is about a proportion. So I'm doing the z-interval for a proportion. So I'm going to pull that in here. So Desmos confidence interval calculator, z-interval for a proportion. There's that bottom one. All right, and then there's my sample size. So I'll just start plugging in these numbers. All right, the P is the proportion in the sample. Right, so it's technically P hat, but it's given it to me as a fraction. This is the number out of this many. So I'm going to write that as a fraction, 117 out of 533. All right, and then it wants me to make, in this case, a 90% confidence interval. So I would change that to 9.9 or 0.90. You can do 90 like that. It wouldn't change anything. And then scroll down here to get your interval. Click the zoom fit. It shows you the interval. You can also get it right there. So I would have that as my interval. My estimation that it is asking me right here would be approximately 0.2195. That's the number that's in the dead center of this interval. And then we go down and up by that margin of error. and get our lower and upper. Okay, I want these rounded to 3 decimal places, so this is already rounded. If it said, for instance, 4 decimal places, again, you could change these to 4s or 2s, you know, however many places that you needed. Alright, now here is a question that's saying that the average cost of the wedding is this. One concerned bride hopes the average is less than what's reported. Right, she surveys 56 recently married couples. The average cost was this amount. Assuming the population standard deviation is this, is there evidence to support the bride's claim at the level of significance? So there's that phrase, level of significance, okay? But when, and it doesn't say the word test in here, but when you see evidence and level of significance and a claim of a value, those types of things let us know that we're doing a hypothesis test, okay? But again, a lot of times the wording of the problem will have the hypothesis test in there. But again, evidence and level of significance are ways to know that we're dealing with a hypothesis test here. So looking up here, I'm on the hypothesis test path now. Is it about a mean or a proportion? It says average cost. So average cost is mean, right? Do we know the population standard deviation or not? Yes or no? Assuming that the population standard deviation is this. So we do know it, okay? So now it's the wording of the problem. Is it worded where it's below? Is it worded where it's above? It's worded where it's equivalent, equal. Average is less than what's reported. So that is going to be a left-tailed test because it says less than. That's that language of below. So there's my hypothesis test calculators. This is about a mean, right? But it's a z-test because the standard deviation is known. So this is a left-tailed z-test for a mean. So I click that calculator, right? MP is the claim value. So that's the 229. All right, the population standard deviation, that's this number 5835. Sample size this time was 56. All right, and then M. Notice little m is sample mean, big M is the population mean. So little m is 28047. And this is a 2% level of significance instead of 0.05, so I'll just change that to a 2. All right, and then the questions it asks. What's the setup? This is a left-tailed test, so we would pick less than right there. The value of the test statistic, there's the test statistic to 2 places, what you typically ask you to do. There it is with many more places, but notice it is in the picture, the drawing, so you could do it from that drawing. All right, and then it wants you to make a conclusion. So because it doesn't fall in that range, there isn't, unfortunately for this bride to be, there is not evidence to suggest that the average cost is significantly less than that. And then finally here is another one where we are seeing the words like claims, level of significance. So that's going to be a hypothesis test. Again, we also see test the claim. This says hypothesis test. So again, we're doing the hypothesis test calculators. That's going to be these down here. This says assume the population distribution is approximately normal. That's not the standard deviation. Above it, it talks about the standard deviation right there, but that's from this sample of 4 teenagers. Notice that's in the exact same sentence. So this standard deviation is not a population standard deviation. So this is a t-test. So it's going to be one of these 3 calculators. And then again, I see Ella collects information. She thinks the area is less than what's reported. So this would be a left-tailed t-test. Plug in all those values. So anyway, that is the criteria, how you would use this kind of breakdown to help you with which calculator from this list of calculators to use.